Imagine typing a simple instruction and watching your 3D software instantly organize a chaotic scene into a perfectly aligned layout, all on its own. This level of control is now possible using the Model Context Protocol, or MCP. It allows an AI model to connect directly to your local desktop applications and operate them. By linking these systems, you can generate 3D assets, animate your cameras, or categorize your file structures without navigating manual menus. To make this work, you must have two specific tools, Blender version 5.1 and the Claude desktop application. This connection replaces manual mouse navigation with text commands, allowing the AI to execute the software's internal operations for you. Step 1 happens entirely outside of your 3D workspace. We have to collect the correct files before connecting. First, you must download Blender 5.1 or newer. The underlying architecture required to accept AI commands does not exist in older releases, and any attempt to connect them will fail. Next, download the desktop app version of Claude, or Claude Code. Standard web browser versions of Claude cannot access your computer's local system files, which is a requirement to control local software. Finally, download the specific Blender MCP add-on package from its official repository and keep the zip file handy. With the modern Blender architecture, a desktop AI client, and the add-on file ready, you have the necessary components to build a secure bridge between the two programs. Open your new installation of Blender 5.1. Take the MCP zip file you downloaded, drag it over your Blender window, and drop it directly into the 3D viewport. Before Blender can install the MCP, it must install a hidden prerequisite called the Labs extension. Because of this background process, your first drag and drop might seem to do nothing. To solve this, drag and drop the zip file into the viewport a second time. To verify the installation, navigate to Edit, click Preferences, select Add-ons, and search for MCP. Tick the checkbox to enable it. Look directly beneath it in the Details section. You are looking for a specific status reading, localhost 9876. Verifying that active server status proves that Blender is broadcasting its internal architecture to your outside operating system. Leave Blender running and switch over to your Claude desktop application. Click your profile name, select Settings, and navigate to the Connectors menu. Browse the available connector list, locate the Blender option, and click Install. If Claude fails to recognize or visually install this connector, you must use a manual fallback. You can force the connection by editing the developer config file. To access this, go back to Settings, click Developer, and click Edit Config. This opens a raw text document formatted as a JSON file. Open that JSON file in Notepad. Paste the Blender configuration syntax provided by the documentation and save the document. The AI now has direct access to read and write instructions to your local Blender server. Arrange your screen so both Claude and Blender are visible side by side. Go to the Claude text box and type a foundational test command. Delete the default cube. Hit Enter. You will see a brief calculation period in the Claude window as the AI translates your instruction into Python code. Over in the adjacent viewport, the object is instantly removed from the scene. This immediate execution confirms the two-way bridge is functional and ready for complex tasks. We can scale this capability up to handle high-friction problems. For instance, heavy scenes loaded with complex subdivision modifiers cause severe viewport lag. Instead of hunting down each object to optimize the file, prompt the AI to write a custom Python script that toggles all modifiers off simultaneously. The AI rapidly calculates the logic and injects a new, fully functional button directly into your Blender user interface. When you click that button, your viewport playback immediately jumps from 7 frames per second up to 24 frames per second. The MCP integration embeds the AI's ability to code directly into the workspace, where it can build and deploy custom tools as you need them.